Hi, and welcome to Dr. V's AP Chemistry webcast. In this webcast, we're going to discuss how to balance redox reactions. Our focus is going to be balancing simple redox reactions. If you need to learn how to balance redox reactions in acidic or basic conditions, I've got a separate webcast for that. A lot of redox reactions can't be balanced by inspection. There's a lot going on with these, so we need some other strategies. We can't just count atoms because we have to take into account the electrons that are transferred. We are going to use half reactions. A lot of times it's easier to figure out what's being oxidized, write that half reaction, what's being reduced, write that half reaction, and then put the two pieces together. And so that can be a useful strategy for balancing redox reactions. The guiding principle is that we have to show conservation of mass and charge when we write the final balanced equation. It's easier to show you how to do this instead of just talking about the process. Let's start by deciding what species is oxidized. So we have this unbalanced net ionic equation. So I'm leaving out the spectator ions. And the first question we should ask ourselves is what species is getting oxidized? And what's the oxidation half reaction? Since gold is going from an oxidation number of 0 to an oxidation number of +3, the gold is oxidized, and our oxidation half reaction involves the loss of 3 electrons. So Au losing 3 electrons to make a gold ion with a +3 charge. What species is reduced? That would be the iron 3 ion. Is going from an oxidation number of +3 to an oxidation number of +2. That's a 1 electron change. So I need to show the iron 3 ion gaining 1 electron to make an iron 2 ion. So now we have the two half reactions, one to show oxidation, one to show reduction, and now we have to talk about how we put them together to write an overall balanced equation. One suggestion that I have, when you write your half reactions, line up your arrows. It makes it a lot easier to keep track of your reactants and your products if your arrows are lined up. In order to write the overall balanced equation, we need to show conservation of charge. And what that means is that the number of electrons lost has to equal the number of electrons gained. When I add these up, I can't have like 2 electrons on the product side. That's not okay. If I look at the gold half reaction, there are 3 electrons lost. If I look at the iron 3 half reaction for the reduction, it's a 1 electron change. But I can't lose 1 electron and gain 3. That doesn't make sense. So what I'm going to do is multiply the iron 3 half reaction by 3. So I have 3 Fe3+ and 3 electrons to make 3 Fe2+. And now that I've done this, the number of electrons on both sides is the same, and they're effectively going to cancel out. And I can then write my overall balanced equation. Au plus 3 Fe3+ makes 3 Fe2+ plus Au3+. Let's work through another example. Tin 4 ions reacting with aluminum metal to make aluminum ions and tin 2 ions. What's the oxidation half reaction? We're looking for the species whose oxidation number goes up. That would be the aluminum. Aluminum making aluminum 3 ions and 3 electrons are lost. Now let's think about our reduction half reaction. The tin 4 ion gains 2 electrons to make a tin 2 ion. And so I lined up my arrows and I've got my 2 half reactions. Now again, I need to have equal numbers of electrons lost and gained. So if I multiply the top half reaction by 2 and the bottom half reaction by 3, I've got a total of 6 electrons in each half reaction, and then they'll cancel. And then I can go and write my overall balanced equation. 3 SN4+ plus 2 aluminum make 2 aluminum ions plus 3 tin 2 ions. Now some half reactions are more complicated. It's beyond the scope of this particular webcast to show you how to write those. When you have reactions occurring in acidic or basic conditions where you might have hydrogen ions and water. For example, water can undergo an oxidation to form oxygen gas and release hydrogen ions. But the balancing process is the same. So if we had this reaction occurring along with the reduction of silver ions, we still need to make sure the number of electrons lost and gained is the same. And so if I multiply the silver ion half reaction by 4, I have 4 electrons gained in the reduction half reaction now, and 4 electrons lost in the oxidation half reaction, and I can add them all up and get an overall equation. So even when I have a more complex half reaction, balancing is really about making sure the number of electrons lost equals the number of electrons gained. And then you add everything up. So just to summarize, half reactions are a useful strategy to balance redox reactions. You write an oxidation half reaction, you write a reduction half reaction, and then multiply the half reactions by some constant so that the number of electrons in each half reaction is equal, and then you add the reactions together. I hope you found this helpful. Subscribe to my channel so you get all my latest videos. Like the video and leave a comment. Practice chemistry every day. That's how you get better.